In general, there are two ways of removing neurotransmitter from the synapse. The first is through reuptake transporters, and the second is enzymatic destruction. It's important to remove neurotransmitter from the synaptic clot for two reasons. One, to ensure the message is relevant. We don't want postsynaptic receptors to be activated after the presynaptic neuron has stopped releasing neurotransmitter. And then two, we want to prevent neurotoxicity. Glutamate is especially dangerous at producing excitotoxicity in the postsynaptic neuron. Getting rid of the excess glutamate from the synapse ensures that the postsynaptic neuron will not experience excitotoxicity. Glutamate is removed from the synapse via excitatory amino acid transporter. This transporter is also present on nearby glial cells. Although monoamines are packaged into vesicles using one common transporter, VMAT, neurotransmitter reuptake from the synapse is done by individual reuptake transporters. Removing serotonin is done by serotonin transporter, or SERT. Dopamine is taken back up into the presynaptic terminal by the dopamine transporter, or DAT. Norepinephrine is taken back up into the presynaptic terminal by the norepinephrine transport, aka NET. The other way of removing neurotransmitter from the synapse is through enzymatic destruction. Acetylcholine does not have a reuptake transporter, but it can be eliminated from the cleft by acetylcholinesterase. Acetylcholinesterase breaks acetylcholine into acetate and choline. Choline can then be taken back up into the presynaptic terminal and converted back into acetylcholine. There are several drugs that inhibit acetylcholinesterase. Because they decrease enzymatic destruction for acetylcholine, they increase acetylcholine availability. And of course, they are not directly activating postsynaptic receptors. Therefore, these drugs are indirect agonists. Monoamines have several different enzymes that can destroy them. One is monoamine oxidase. There are actually two subcategories of monoamine oxidase. The first, MAOB, is specific for dopamine. MAOA can eliminate serotonin, melatonin, norepinephrine, epinephrine, and dopamine from the synapse. Monoamine oxidase converts monoamines into inert substances that cannot activate postsynaptic receptors. Deprenyl blocks MAOB, preventing the destruction of dopamine. Deprenyl can be used to treat the early stages of Parkinson's disease, which is categorized by decreased dopamine availability. Another enzyme, catechol O-methyltransferase, or COMT, can remove catecholamine monoamines from the cleft. These include dopamine and norepinephrine, as well as epinephrine. Because serotonin is an indolamine monoamine, COMT will not eliminate serotonin.